my name is Dave Gunter and welcome. Today on the Cyber 101 series, we're going to talk a little bit about fit for purpose, and particularly what that means from a cyber context. So first, let's talk about the term fit for purpose. Talk about what does that entail? Fit for purpose is basically a quality assurance program for design principles. You can say it a lot of different ways, but there are some great examples of that. One of the examples is the SubSafe program by the U.S. Navy. It was established back in the 60s. It was the program they put together for the construction of nuclear submarines. It has all the aspects from a design standpoint. It has design, it has materials, it has fabrication, and it has testing. And there are steps in each of these processes, checks and counter checks, to make sure that the submarine is fit for purpose. It's built to a specific operational window and it delivers what it was designed to do. So that's the basics of fit for purpose. Now, we have to take a step further. When you're doing this in the automation world or operation of maintenance, you have to look at items like what's banned. There are banned technologies out there from the Department of Commerce. State Department has them listed, and you can see what those are. There's also your company may have, or your municipality may have, banned technology that they do not allow on their IT network. You also want to stay away from anything that's obsolete or anything that's within 5 years of the window of obsolescence. That can be a challenge because you really got to dig in deep. But when we look at fit for purpose from a cyber standpoint, it goes a little deeper. It goes to the point of when you do fit for purpose, you look at form, fit, function, you look at the safety aspect of it, you look at a host of topics. Now you're being asked to look at it from a cyber perspective. That perspective is interesting because you also look at budget. When you look at budget, let's be honest, you want to leverage that new technology when you can. You leverage it and you find out, hey, there is a lower cost widget to do what I want it to do. Fantastic. Let's say that widget is a PC that is an HMI, human machine interface. It's a PLC, it's a soft control engine. It has I/O attached to it, and it has the operations runtime, and it has the engineering application to download to that soft control engine. So there you have it, all in one box. The processor, the viewer, the application to engineer it, and the I/O. Connect it up and go. It seems like a very cost-effective approach on the surface. However, you have to take a step back and think about cyber. What does that do from a cyber standpoint? You know, from a cyber standpoint, it gives you one piece of equipment, a common attack surface that you can do many things. You can spoof the operator with the HMI. You can control with the HMI. You can actually download to the PLC, the soft control engine. You can interrupt I/O tables and change variables. There's a lot of things you can do by just compromising one machine. So typically we don't see these a lot in the space. However, they are creeping in there. They do have a place, but you also have to look at your consequence of compromise. If your facility is not that, does not have that kind of footprint of critical infrastructure or safety or 24/7 operations and things like that, maybe this application, maybe this technology and the application you have would fit. However, really take a look at that, dive deep, understand your risks. You know them, you're in operation and maintenance. Understand those risks and say, wait a minute, do I really want one device that does it all for a low cost, but it gives me one common attack vector? At the same time, if it's in the safety application, it's something we would never do. You really don't want all that stuff in one for a safety instrumented system. It just doesn't happen. They're fault tolerant, high availability. That's not a device you would use in those types of applications. So understand what your risks are, understand what your consequence of compromises are, and make sure you put them into your fit for purpose thought process, your design principles of what you want to build, your uptime, your risk availability, and just understand that. It's very important. So join us for the next topic coming up soon.